Welcome to another episode of mLab, or Mbadika Laboratory, where we explore ways to bring our ideas to life. I'm your host, Netia McCray. In past episodes, we used CAD, or computer-aided design, alongside our 3D printer and electronic station to bring to life a power glove inspired by Captain Marvel and a General Mayhem cookie cutter inspired by the Lego Movie 2. This week, we'll be diving right back into the Marvel Universe in anticipation of Avengers Endgame. Roll the clip!
I look around at us, you know what I see?
Possibility. You think you know how the world works?
The world is changing. We need heroes. Whatever it takes.
Warning, in case you haven't seen the previous film, spoiler alert. In Avengers Infinity War, Thanos, using the Infinity Gauntlet with the snap of his fingers, transformed half the universe, including the Avengers, into dust. Now, the Avengers have taken up the new mantle of avenging not only the fallen on planet Earth, but the entire universe. Therefore, I wanted to create a project that sums up the theme of over a decade of Marvel films from my point of view. To be a Marvel is to be a wonderful or marvelous person. Anyone can be a Marvel, regardless of your background or situation. Sometimes we question whether we are truly marvelous, but as the legendary Stan Lee of Marvel Comics once said to Spider-Man, it always fits, eventually. Looking back at over 10 years of the Marvel Cinematic Universe, or MCU, I couldn't help but zero in on one of the greatest opening scenes of all time, in my humble opinion. Watching carefully and weren't too distracted by a dancing and adorable Groot, you might have caught a glimpse of an item that holds immense value in the Marvel Universe and plays an important role in Guardians of the Galaxy Volume 2. Anulax Batteries, not to be confused with Harbulary batteries. After thinking a little further on how to honor the MCU, and I mean for an extensive period of time, it occurred to me. In the Marvel Universe, Anulax batteries are highly sought after for their immense power. In our world, ideas and those who create them are as powerful and as highly sought after as Anulax batteries. So how about we create our version of Anulax batteries to symbolize the untapped potential for greatness within each of us to be Marvels in our own right? As you can see here, in order to make our Anulax battery a reality, I had to use several techniques, including 3D printing, electronics, and a little bit of crafting. This project can be done solo or as a family project to explore the Marvel Universe in a fun and engaging way. To begin, we need to put our ideas for our vision of an Anulax battery to our sketchpad. Just like before, I'm using my iPad and pencil in order to sketch my vision for my Anulax battery. Feel free to use any sketching alternatives, including paper and pencil. If we want our Anulax battery to look similar to those featured in the Guardians of the Galaxy opening scene, glow and all, we want our Anulax battery to consist of 3 parts: an end cap, a bulb, and a middle joint. Since I want to ensure that I make my Anulax battery an accurate representation of what makes me a Marvel in my own right, I've decided to design my end cap around the Mbadika logo. For the bulb, I want to offer a peek into the immense power of our Anulax battery. Hence, I wanted to be somewhat transparent to showcase the glow of our battery, while featuring a few curves. Finally, I want to design the middle to hold the electronics for our Anulax battery, as well as showcase the Mbadika logo. Now that we have our sketch, I'm going to use this as a reference or a battle plan for how I'm going to approach my Anulax battery. For our Anulax battery, we're going to use CAD software. CAD software, or computer-aided design software, is a program that allows us, with the assistance of or aid of computers to design marvelous objects, whether it is a crown inspired by Queen Ramonda or even an Eye of Agamotto inspired by Doctor Strange. In order to transform our Anulax battery sketch from earlier into a 3D model, also known as a CAD model, we're going to be primarily using Tinkercad. In this mLab project, like always, you can use other CAD software such as SolidWorks, Rhino, or Autodesk Fusion 360. On a clean work plane, similar to a canvas or a blank piece of paper, we can create our Anulax battery. First, we're going to craft our end cap by bringing a cylinder from the Basic Shapes toolbar onto our work plane. Given we want our end cap, similar to a bottle cap, to fit on the end of our actual bulb, we're going to transform our cylinder by bringing a cylinder onto our work plane. For our duplicate cylinder, we're going to transform it into a hole using the Shape toolbar. Next, we're going to make our duplicate cylinder slightly smaller and raise it just above our previous cylinder in order to ensure we leave just enough room for it to cover the top of our bulb. Now select all objects and group. Given that we always strive to be a little extra, let's bring another basic shape, like the roof shape, onto our work plane for us to create an adornment for our Anulax battery. And perfect. Next, we need to CAD our bulb. For my bulb, I want to imitate hand-blown glass by including very unique round and curvy shapes. Let's begin by moving our end cap to the far corner of our work plane to provide ourselves enough space to work on our bulb. Now that we have a little space, let's grab a sphere from the Basic Shapes toolbar and smush it by altering its height until it looks like a marshmallow. Next, we're going to grab a half sphere, flip it, and raise it until it sits on top of our smushed sphere. Now feel free to play around with your bulb until you get a shape that you adore. Now, given we want at least 10mm LED to fit inside, just in case we decide to live by the motto, go big or go home, we need to create a hole in order to create space for our LED to fit inside our bulb. So let's grab a cylinder and bring it to our bulb CAD model, make it a hole, select all, align, and then group once again. Next, we need to ensure our LED, the symbolic power for our Anulax battery, fits. So we're going to use a feature never before seen on mLab. You ready? We're going to bring an LED from our Circuits Components toolbar. Yeah, I thought you liked that. Journeying to our Basic Shapes toolbar, we're going to use the drop-down menu to pull up our Circuits Components toolbar and select an LED. Once we've obtained our LED, let's move our LED over to our bulb in order to ensure that it fits, and boom! It's looking pretty on point if I do say so myself. Now that we have our end cap and bulb, it's time for our middle joint to bring it all together. Our middle joint is where the electronics for our Anulax battery will reside. In order to power our Anulax battery, we'll be creating a simple LED circuit, which includes a coin cell battery holder, push button, and of course, our LED. All these components will be placed inside of our middle joint. Therefore, we need to once again create a bit of space on our work plane because the middle joint is gonna need it. So let's move our bulb and have it join our end cap on the back of the work plane and begin modeling our middle joint. Just like we did for the end cap, we're going to start with the cylinder and create a cap in order to ensure the middle joint can serve as an end cap for the bottom of our bulb. Next, we're going to add an additional hole for our LED to emerge from one side of a middle joint. Select all the shapes, align, and then group. Now we have our middle joint, we need to make room for the push button of our circuit. Therefore, we're going to duplicate, flip, align, and group our two middle joints. Once we have a more robust middle joint, we are going to use a measuring tool to create a hole or a cutout for our push button. You can use a typical push button, like this one here, and create a hole based on the measurements you obtained by using a ruler. However, I want to be a little more accurate, so I'm going to use calipers in order to measure the diameter or the width of my push button. Whatever you do, make sure to measure twice to ensure an accurate hole for your push button. So I'm going to open up my calipers here, place my push button in between, and it looks like I have a diameter of about 13.5 millimeters. Armed with this knowledge, I'm going to create a hole through my middle joint with the same diameter as this push button, with a little cushion in case I'm slightly off. Finally, just to make sure our Anulax battery circuit will fit, we're going to use a coin cell battery and an LED from our circuit components toolbar to conduct a quick test with our CAD models. Remember, always make sure you add a little space around your components or a margin to ensure a tight fit isn't too tight. Once we have our middle joint, let's complete the second half of our Anulax battery, which can be summed up in 15 words. Duplicate the end cap, rotate, duplicate the bulb, rotate, align, checked, select all, and group. Sounds like the hook for my next single, Anulax. Corny jokes aside, when assembled, our Anulax battery will look something like this. Now, it's time to bring our Anulax battery CAD model to life using our 3D printer, a Dremel 3D20. To print, let's first load our CAD model to a 3D slicing software. 3D slicing software, such as Ultimaker's Cura or Dremel's DigiLab, is software that translates our CAD model or 3D model into thousands of slices, the 3D slicing in 3D slicing software. Afterwards, the software creates instructions known as G-code for our 3D printer to know exactly what to print for each slice to form our 3D print. Once we have our G-code, I'm going to download it onto my SD card, remove, insert, and select my file and print. Side note, given we want our Anulax battery to have an internal glow, the filament or material we're using inside of our 3D printer is clear. If you want to go above and beyond, you can even 3D print your Anulax battery using glow-in-the-dark filament or even filament that smells like chocolate. Just make sure that your Anulax battery shows up how marvelous you are. While we are waiting for our Anulax batteries to finish 3D printing, let's see how folks in the city of Boston unleash their inner marvel. Feel free to find a seat. At your seat should be some LEDs, a push button, and some 3D printed components.
That'd be pretty cool if I made something like that.
Yeah. Are they good? Today, mLab, or Mbadika Laboratory, is here at the South End Technology Center hosting a workshop around our Anulax Battery project inspired by Avengers Endgame, in which students will be exploring 3D printing and electronics to bring their own Anulax battery to life. Just like Anulax batteries are highly sought after in the Marvel Universe, we want students here to realize their potential for greatness and their potential to be innovative makers is highly sought after in this universe. And then you can do your your two LEDs in two ways, right? You can do positive to negative, or you can actually have them split.
The purpose of SETC, it's a community technology center. It grew out of the needs of the community, and it is there to provide access to the latest technologies to people who are at risk of being excluded.
Yes.
I think I got it.
If you think you got it, go ahead and create a test circuit with it.
All the young people that you see today, they're part of our Learn to Teach, Teach to Learn program. We pay them to learn, build, and then go out and teach what they've learned in the community.
This is where I'm going to see how well you've learned from Susan. And from each other. It is Learn to Teach, Teach to Learn, in one sense. The circuit you need to build is a 2 LED circuit. one for one end, one for the other. It should be powered using only one coin cell battery and one coin cell battery holder. Your task is to create an Anulax battery that is operational with that push button. The reason I'm only giving you what that circuit should look like, this is the challenge of reverse engineering. You have all these components before you, but you need to figure out how you're going to recreate the product. If you want to experiment with different LEDs, red and blue flashing.
We have flickering and we have color changing.
Fast and slow.
Yeah, fast and slow.
I never heard of the idea of reverse engineering, but like seeing that I could like make it myself, because I never thought that I could. You realize like it's not that hard. It's actually, you know, just positives connect to positives and positives connect to positives, you know? And then negatives connect to negatives and negatives connect to negatives. That's literally all it is.
Okay, you're gonna get a crash course on half a semester in physics.
I'm looking towards mechanical engineering for college, and so I'd like to use these skills. And since I like understand a little bit of like circuitry, that might come in later, and also a bit of coding. So I feel as if like using those skills, I might be like, you know, just like a few steps ahead of everyone else in my class.
We need 3 volts to go through both, because otherwise it'll just be a pitiful 1.1 voltage going through this, and we ain't gonna see that in that LED. See? Physics and electronics all on a Saturday.
There's just so much untapped potential, and I think that the example provided by the Black Panther, you know, to sort of demonstrate that, you know, basically says that, you know, people in communities all over the globe that you might not have heard of or seen of, when they have this type of technology access, there's no telling. Sky's the limit in terms of what they can create.
Boom. So now we're gonna do our hookup wire. So we're gonna need to make sure that when this goes inside, it's gonna light up. So do you wanna press that button?
It works.
It works.
I think these batteries, don't they save the universe? So in a little way, you know, empowering the young people, it's a symbol of their capacity to change the world.
If you'd like to learn more about an Anulax Battery project or even build your very own, don't forget to visit our website at mbadika.org or check out our Twitter, Facebook, and Instagram to learn more about this and other exciting projects from Mbadika Laboratory. Until next time, build, make, learn. Wow, that actually worked. Well, if the community at the South End Technology Center doesn't showcase what it means to be a Marvel, I'm not sure anyone can. Therefore, we definitely need to finish our Anulax battery in order to join our fellow Marvels. To do so, we will need our 3D printed Anulax battery components, 2 LEDs, a coin cell battery holder, push button, jumper wires, and of course, thanks Groot, a pair of long needle nose pliers. First, we need to create a simple circuit by wiring our 2 LEDs and coin cell battery holder as such. The positive leg of our LEDs need to connect to the positive lead from our coin cell battery holder. The negative leg of our LEDs will need to connect to either the negative leg of our coin cell battery holder, or as I did here, we can connect them to each other. Pretty much like thing 1 and thing 2. Next, we're going to connect the jumper wire to each of the remaining legs of each LED. Then we'll take the bottom half of our Anulax battery and place our push button inside. Given the type of push button I'm using, I have to first unscrew the backing, then place the push button inside. Gonna take the actual backing, place it inside, and just like you probably remember from school, righty-tighty, lefty-loosey. And there you have it. The push button's in, and now to see if it's comfortable with the little wiggle. Looks pretty comfortable to me. Once we have ensured that our push button's well into our Anulax battery component, we're gonna take our long nose, needle nose pliers and bend the ends of our jumper wires through each of the holes on the bottom of our push button, as such. So first, we're gonna take the first actual jumper wire, feed the metal end through, hook up, take our pliers, press down, crimp, as such. Then we're going to rotate in order to feed the next end or metal end of our jumper wires through the hole of the push button. Hold it, take our long nose needle nose pliers, crimp again, make sure both sides are pretty steady and ready for showtime. And now, as with all electronics, let's give this circuit a quick test and let there be light. Just like we did with our previous mLab project, the Captain Marvel Power Glove, we can further secure our electronics by either soldering and using our hot glue gun. Now that we're armed with our wired Anulax battery, we can attach the top of our Anulax battery. But be very careful. We don't want to disturb the electronics we just spent so much time assembling. After assembly, you should have something that looks sort of like this. I've even added a little nod to the Avengers in this version. So we're gonna give this a quick battery test. And it works, ta-da! For security, once you are confident your project is ready, you can add a layer of hot glue or rubber cement around any gaps in your Anulax battery project. This will not only secure your battery, but it will also protect it from the elements, such as water or dirt, from damaging your circuit, like you can do right here. I did some a little bit around here because I'm a little paranoid. And once you have that, feel free to continue to expand and prototype on this version. For example, I decided to use an even more transparent filament in order to create a second version of my Anulax battery to make it worthy of any Marvel superhero. This project is simply a canvas to express what makes you marvelous. Now, before Thanos turns me into dust, I would like to thank everyone who helped make this mLab project a reality. The Timothy Smith Network, Autodesk, the South End Technology Center, and last but certainly not least, Boston Neighborhood Network. If you would like to explore this mLab project further, or even make your own Anulax battery, check out our website, mbadika.org, as well as our Facebook, Twitter, and Instagram for this and other cool mLab projects. It will also be where we will be posting about our mLab projects, celebrating everything Avengers in celebration of Avengers Endgame. Now, until next time. Sorry, could we run that back again? One sec. Now, until next time, build, make, learn.